Good morning student, my name is Noor Alam. I am Maths faculty of Rajeev classes. Today I am going to discuss about the limit. Now what is limit? Let y is equal to fx be a function which is defined in the neighborhood of x is equal to a, but not at the point, not necessarily at the point a. Now basically we are going to discuss the behavior or the tendency of the function at the point x is equal to a, and when we move to the point a, x is equal to a from the left hand side and as well as from the right hand side, what will be the tendency of the function, what is the nature of the function, that we are going to discuss. And in the case of limiting case, when the distance between the x minus a is very small but not equal to 0, but it is very small but not equal to 0, is called the limit of the function, and we write as limit x tends to a if x is equal to a. What does it actually mean? Now let us consider one example to give the explanation of this definition. Let us consider one example. Fx is equal to x square minus 4 by x minus 2. Now what is the value of the function when x is 2? We know that x is 2 is 0 by 0, which is meaningless, but except 2 when you move to the point from the left hand side, then we get the value which is more closer and closer to the 4 but not equal to the 4. Now when we move from the value which is just greater than 2 from the right hand side, we will see that the value of the function is not 4 but it moves towards the 4 and it is more closer to the 4 point something. So we get, by taking the value of 2.1 by f of 2.01, in this way we find that the value is more and more closer to 4 but not actually 4. So in case of limit, what do we see that to find the value of the limit at a certain point, we have to check the left tendency as well as the right tendency of the function. If both the tendency approaches to give the same value, then we can say that the limit of the function exists. But in that case, the point should not be within the domain. It is not necessarily, it may not be in the domain, but the function should be defined in the neighborhood. It is important, otherwise you cannot find the limit. You say that the limit cannot exist. Now the following cases arises when we are finding the limit. First of all, case 1, both the tendency of the functions are same. Both the tendency of the function are same. I am considering one example. Here we see that when we approaches to the point 0, the y is equal to fx function moves to a value. When we come from the right hand side, then again we see that the function approaches at the same value and the value of the function is nothing but a. So in that case, left tendency of the function, left tendency is equal to the right tendency of the function, and we say that the limit exists of this function. Now case 2, it can happen that a function when we comes to the certain point, suppose we take the point x is equal to a, so the function from the left hand side we approach, the function moves to a certain value, suppose the value is L1, and when we approach to the point a from the right hand side, the value which is just greater than a, the function are moving towards the another value whose height is L2, or give the value L2. In this case, L1 value and L2 value are not equal, and we say that the limit will not exist. The third case may arise. That at the point A, the function, when we move towards the A from the left hand side or from the right hand side, we never talk about their tendency. In that situation, we find that the function has the erotic in nature. That means it's oscillating, and we cannot say particularly in which value the function is moving. In that case, since the function shows the erotic behavior, we can say that the limit will not exist. Here also we say that limit will not exist. Limit will not exist. Now, from the above discussion, we can say that to a function has a limit at a particular point x is equal to a, then the function must be defined in that interval and must have the unique tendency. Unique tendency. Now, some misconception a student has about the limit that limit should always be a finite value. It is not true. A function y is equal to fx when x tends to a does not always have a finite value. It will have the infinite value also. In that case, we show that the limit will exist. Now, taking one example, limit, suppose I am taking one function, limit x tends to 0, 1 by mod of x. The function shows in this way. Now, when we approach it towards 0, then the function moves towards the infinity, towards the plus infinity. From both sides, the value, when the value of the x is just greater than a, that means when we come from the right hand side, and when we come from the left hand side, when the value of x is just less than a, in both the situation, function will move to plus infinity, approaches to plus infinity, and we say that the limit of the function exists and this is equal to plus infinity. Now I am taking another example, limit x tends to 0, 1 by minus of mod of sine of x. Now this function, we see that has the nature like this. That means from both the tendency left as well as right tendency of the function is going to minus infinity. Then we say that this function is also has the limit and the limit value of the function is minus infinity. Now case 3, when we consider, we see that limit x tends to 0, 1 by x. Now this function, from the graph of the function, we can easily say that whether the limit exists or not. Now this function is moving like this. When we move from the right hand side of the 0, the function is moving towards the plus infinity. But when we come from the left hand side, the left tendency of the function is minus infinity. That means left tendency is minus infinity and right tendency is plus infinity, which are not equal. Then we can say that the limit of the function is will not exist. Now, from this above discussion, we can say that when we say the function is defined at the point, when we say that function fx is defined at the point x is equal to a, it does not always mean that limit x tends to a, fx is equal to a. It does not mean that. It is not always true. Or it can be seen that sometimes the limit value exists but the functional value f of a does not exist, and sometimes the functional value exists but the function is not defined in the neighborhood, and if it is defined in the neighborhood of the point, then the left hand tendency as well as the right hand tendency are not equal. Now next point is left hand limit and right hand limit. Left limit, we call that is left limit and right hand limit. Left limit and right hand limit. Generally, the left tendency of a function is called left hand limit and right tendency of the function is called the right hand limit. Now left tendency generally written as f of a. When we consider the point x is equal to a, the left hand is written as f of a minus 0 or f of simply a minus, and it is defined as limit h tends to 0 f of a minus h. The right limit is defined as f of a plus 0 or simply written as f of a plus, and it is defined as limit h tends to 0 f of a plus h. F of a plus h. Now we will see one important criteria, that is called necessary and sufficient condition. Necessary and sufficient condition. For limit existence for the limit. Necessary. What is the necessary and sufficient condition so that the limit of a function exists at a certain point? The condition says that the left hand limit LHL and right hand limit RHL should be equal. This is called the necessary and sufficient condition. If a function has a limit at the point x is equal to a, it means that left hand limit, right hand limit must be equal. Or if left hand limit, right hand limit equal at a particular point x is equal to a, then you can say that the function has the limit at that point. Now the question arises, in what situation limit does not exist? So reasons limit does not exist or limit will not exist. We discussed both the cases. First criteria, we existence of the limit. Next criteria is reasons the limit will not exist. First criteria, we will discuss that in the neighborhood, if the function is not defined in the neighborhood of that point, then we say that limit will not exist. Now we consider one example. Very simple example is f of x is equal to root over of x minus 1, and we take one point, that is x is equal to 1. We are going to check the limit at this point. Now x minus 1, when we come from the right hand side, then the value of x is just greater than 1 and we get the positive square root quantity. But when we discuss the left hand limit, then we come from the left hand side of 1, the value of x is just less than 1, then this quantity becomes the root over minus negative sign. That means complex number come into the existence. Complex number. Then we can say that limit will not exist. Therefore, what we see that in the neighborhood of the point 1 point, right neighborhood the function is defined, in the left neighborhood the function is not defined. Therefore, we say that the limit is not exist. One more example where the limit will not exist in the neighborhood. Take the example fx is equal to sec inverse sin x. And we take the point x is equal to pi by 2. We know that sin pi by 2 is 1. So if sin pi by 2 is 1, then we can easily calculate the sec inverse of sin pi by 2, that is sec inverse of 1, whose value is sec inverse 0. We know that sec inverse 1 is 0. Now what will happen when we take the value just more than pi by 2? So in that case, sin pi by 2 plus gives a value which is less than 1, and in that case sec inverse 1 is not defined. We know that sec inverse is defined more than 1 or less than or minus 1. When we take any value which is less than pi by 2, in that situation also, in case of left hand limit, we see that we have sec inverse of sin of pi by 2 minus 0. In that case again sec inverse of some quantity which is less than 1, again sec is not defined. That means when we take limit x tends to pi by 2 minus sec inverse sin of pi by 2, sin of x will not exist. You can say that it does not exist. Reason is what? In that case sin x, limit x tends to pi by 2 minus, gives a value which is less than 1. And this value less than 1 and less than 1 value sec inverse is not defined. That's why in the neighborhood of the point the function is not defined. Another case we can consider log of x minus 1 divided by x square plus x plus 1. In that case limit x tends to 1. When we take 1 plus, the function is defined. But when we take 1 minus, then when the value of x is slightly less than 1, then we get the log of negative quantity, which is undefined. So therefore we say that the function will not, the limit will not exist. So in one case, whether the function is not defined in the neighborhood, the limit will not exist. Second case, if the function shows the erratic behavior. Now consider one function, fx is equal to cos of 1 by x. We know that when x is not equal to 0, we get the finite value of this function. But when x moves towards the 0, cos 1 by x shows the erratic nature. That means we get the value of the function like this. That means its oscillating when x tending to 0. Therefore, we cannot say what is the limit of this function. We say that limit will not exist. Now the third and the last case, whether the limit will not exist, we can say that when the left hand limit and the right hand limit are not equal. Consider one example, that is fx is equal to fractional part of x. Graph of the function is like this. When we consider 1, then what will happen? Right hand limit. Right hand limit is 0 of this function, but left hand limit is 1. So both the limit exist but not finite. We can say that limit will not exist. Now, when we summarize this theory, we can conclude that the limit of a function exists when the left hand limit as well as the right hand limit are equal. Both are finite. If they are not finite, then they will give both will give left and right hand limit. Both will either plus infinity or minus infinity. Then we say that limit will exist. Or limit will not exist. There are three cases arises. Number one, in the neighborhood of the function will not be defined. Number one case. Number two case, function will show the erotic nature. Number third case, left and right hand limit both exist but they are not finite. Now the symbol x is equal to a, x is equal to a fx. This symbol says that when we approach to the point x at the point x is equal to a from left and right, it is only possible when a is the finite value. When a is finite, but when a is infinite, like plus infinity or minus infinity, it does not says the same meaning. In that case, we can say that like limit extends to plus infinity fx. Now, what does it mean? Limit extends to plus infinity. We can say that the function we take only the left hand limit. We only consider left hand limit because we can't go beyond the infinity. So we only take the left hand limit of this function fx when x assume a very large positive number. And when we say that limit extends to minus infinity fx, then it means that we take the right hand limit of this function when x assumes a very high negative, very large negative number. When x assumes a very large negative values, then we take the right hand limit of this function, limit extends to minus infinity fx. Now, some important results that we use in case of limit. Important result. Point number 1, if px is a polynomial, then limit extends to a, px is equal to p. Number 2, limit extends to a, limit extends to 0, sin x by x is equal to limit extends to 0, tan x by x is equal to limit extends to 0, cos x is equal to 1. Number 3, limit extends to 0, e to the power x minus 1, e to the power x minus 1 by x is equal to 1, and limit extends to 0. Point number 4, a to the power x minus 1 by x is equal to log of a base e. Point number 4, limit extends to 0.5, limit extends to 0, x to the power n minus a to the power n divided by x to the power n minus a to the power n is written as n by n, a to the power n minus 1. 6, limit extends to 0, log of base e, x plus 1 by x is 1. Number 7, limit extends to 0, 1 plus x whole to the power n minus 1 by x is equal to n. Number 9, limit extends to 0, 1 plus x, 1 plus 1 by x, 1 plus x whole to the power 1 by x is equal to e. Number 10, limit extends to 0, 1 plus 1 by x whole to the power x, and you can write as infinity. Then equivalent gives e. Now, all the 10 formula will give the same result if we substitute that limit extends to a, f of x is equal to a, f of x is equal to 0, then we get the same result. I'll give you one example, like limit extends to a, sine of fx by x gives the same result 1. Similarly others. Now there are some basic theorem in limit. Basic theorems in limit. Suppose there are two functions, one is fx and limit extends to a, fx is equal to a1, limit extends to a, gx is equal to n2, where n1 and n2 both are finite. Then we have number 1, limit extends to a, fx plus or minus gx is equal to same as limit extends to a, fx plus or minus limit extends to a, gx, which is equal to L1 plus minus L2. Number 2, limit extends to a, fx multiplied with gx, which is same as limit extends to a, fx into limit extends to a, gx. That is equal to L1 into L2. Now we know that limit extends to 0, sin x by x is equal to 1. Can we write in this way? Limit extends to 0, sin x into limit extends to 0, 1 by x is equal to 1. That means limit extends to 0 is 0 and limit 1 by x is supposed to be within the infinity or not defined quantity. It does not define is equal to 1. Does it possible that 1 is equal to 0 into something meaningless is 1? So we arrive at the contradiction due to the wrong use of this theorem. Why? Because here says that the product of the limit exists only when both should be the finite. But here this limit is not finite. That's why we cannot break up this limit sin x by x as the product of two functions. That is the wrong concept. We can't use it. Number 3, limit extends to a, fx by gx is written as limit extends to a, fx divided by limit extends to a, gx, which is equal to L1 by L2, where L2 is not equal to 0. Number 4, limit extends to a, f of g of x is same as limit extends to a log of fx or log of gx is same as log of limit extends to a, g of x is equal to log of e L2, where L2 should be positive. Now since in the case fx is less than gx for all x belongs to the neighborhood of the point x is equal to a, then in that situation limit extends to a, fx less than limit extends to a, gx. Now next important concept is that is called sandwich theorem. Suppose there are three functions fx, gx and hx. Fx, gx and hx such that f of x less than equal to g of x less than equal to h of x for all x belonging to neighborhood of the point. ABD of the point x is equal to a. Such that f of x less than equal to g of x less than equal to h of x, and we have limit extends to a, f of x is equal to suppose a, as well as limit extends to a, hx is equal to a. Then we will say that by sandwich theorem this implies limit extends to a, g of x is equal to a. Now this theorem, sandwich theorem, may be applied when we cannot calculate the gx or we cannot find the limit of gx directly by our conventional method. Then it is easy. When it is easy to find the function fx and hx, then we can easily find the or apply the sandwich theorem to find the limit of gx. So I am taking one example for the sandwich theorem. Suppose we are want to find sin x by x limit x tends to infinity. How do you find this using the Sandwich theorem? What is the result of this quantity? What is the limit of this value? Now I am taking f of x 1 by x minus 1 by x and h of x is equal to 1 by x. Because we know that sin x less than equal to 1 greater equal to minus 1. Now multiply by x 1 by x, we get sin x by x less than equal to 1 by x greater equal to minus 1 by x. Now the limit of x tends to infinity minus 1 by x is equal to 0, as well as limit x tends to infinity 1 by x. I am taking positive infinity. Now 1 by x is 0. So therefore we can say that sin x by x tends to 0 as x tends to infinity. As x tends to infinity. Now most of the student, again after the whole discussion of the theory, again the student have the problem. So what is the limit? Can you give the practical example so that we can easily understand what do you mean by the limit? I am giving you at the end of this topic that what is the practical significance or practical phenomenon of the limit. I will give you one examples. Now, what is the practical idea about the limit? Now consider that there is a party going on and your friends has invited you for his birthday party, and there is a piece of cake, and every time what he is doing, every time he cut the cake and will give you half of the cake to you. So in the first attempt, when n is equal to 1, he will give you half of the cake. So therefore, when he give you half of the cake, so you have half cake of the piece and your friend has half. So I am doing in this way, your friend and you. Your friend and you. So first, after the first cut, you have half, your friend have half. Next, when n is equal to 2, second time, your friend again gives you half of his cake piece. Half of its cake piece. So that means next time again half. Your friend has only 1/4, and you have in that time 1 by 2 plus 1 by 4. Now in third case, your friend again cut the cake into the two pieces, and again he will make it half, and he will give you 1/8 of the cake he has, and you have 1 by 2, 1 by 4, 1 by 8 part of the cake. Now the question is, at what or when your friend does not have any cake? Is it possible that your friend has empty cake or does not have possess any cake? Now there is no way, or your friend has the 0 cake or nothing, because every time he has cut the cake into the two pieces and gives to you. So therefore, after n is equal to infinite attempt, what you have? You have the whole cake, but except the one particle of the cake with your friends. A very little amount, you can say that it is an atom. One atom of the cake your friend has, and you have the whole cake. But never you get the whole cake from your friends, because every time you cut the cake into the two pieces and give to you half. So therefore, the number of cuts is nothing but the concept of infinity, and what's the cake your friend have, this amount of cake gives you the idea about the limit. Okay, now if you want, you can consider another example. That suppose there is a wall and distance between wall and you is 10 meter. Distance between you and wall is 10 meter. Every time you decided to cover the half distance by jumping, you cover the half distance from the wall. So when you jump first time, you cover the 5 meter and rest is 5 meter. When you jump second time, you cover the 2.5 meter again and left is 2.5 meter. Now the question is, when you reach the wall in future, Now answer is no, you can never reach the wall because at every time you jump and you just cover the half of the distance. So at the moment, sometimes the distance between you and wall, become very less, very small, but cannot be zero. This is the idea of the limit. You cannot attain that point. You cannot just go to the wall, but there is a small distance always maintained between you and wall, and this is we call the limit concept. And in the beginning, we are going to take one example, that is function is fx is equal to x square minus 4 by x minus 2. Now, how to calculate this value? Suppose we can calculate in this way: x plus 2 into x minus 2 divided by x minus 2. Now, x minus 2 get cancelled. You have x plus 2 only. We can consider this because we know that our value is x is not equal to 2 but tending to 2. So, therefore, if x is tending to 4 when x tends to 2. Now, geometrically it means what? If you want to see it geometrically, you can see that now there is a point when it comes from the value just less than x, you are approaching towards this point. This is nothing but 4. The value of the function at this point is not defined, but when you come from the value which is just greater than 2, that is from the right hand side, again you are approaching to the same value, that is you are moving towards the 4. So we can say that the limit of the function exists and the limiting value of the function is 4, but value of the function at the point 2 is not defined. It is meaningless. Thank you very much.